I'm Dr. N. Satyashila, Assistant Professor, Department of ECE, Rohini College of Engineering and Technology. The course code is 24 EC304. The course name is Electronic Devices for Industrial Applications, Unit 3, Transistors and Industrial Switching Applications. The topic we are going to discuss today is High Efficiency Switching Power Supplies, that is SMPS. On completion, the students will able to design an SMPS, choose proper rated SMPS for the electronic appliances. High efficient switching power supplies. High efficient switching power supplies convert power using high frequency switching, resulting in smaller size, lighter weight and high efficient, often 80 to 95% compared to linear supplies. This is achieved by rapidly turning a switching transistor on and off, which minimizes energy loss as heat. They are identical for applications where space is limited or power is a concern, and they handle high current applications well. SMPS block diagram. SMPS is an efficient power supply that converts electrical power using switching devices that turn on and off at high frequencies and energies to reach components like inductor or capacitor to supply power when the switching device is in its non-conduction state. The main components are a rectifier, filter, inverter, transformer and feedback control. The SMPS block diagram working can be divided into several stages. Here is the block diagram of SMPS. The first stage is the input stage. AC input is given. The SMPS circuit receives AC input from the main supplies. The next step is rectification and filtering. The AC voltage is rectified using a bridge rectifier to convert it into a pulsating DC voltage. This DC voltage is then filtered using capacitors to produce a relative smooth DC voltage. High frequency switching. Switching transistors are used here. A high frequency switching transistors like a MOSFET or IGBT is used to chop the DC voltage into a high frequency AC signal. The switching frequency can range from 20 kHz to several MHz. PWM control. The switching transistor is controlled by a pulse width modulation controller. The duty cycle of the pulse width modulation signal determines the output voltage. The third stage is the transformer stage. High frequency transformer. The high frequency AC signal is fed into a high frequency transformer. This transformer steps up or step down the voltage to the desired level. The high frequency transformers differ significantly from traditional transformers. Output stage, rectification and filtering are involved here. In the rectification process, the high frequency AC signal from the transformer secondary winding is rectified using diodes. That is, typically Schottky diodes are used due to their fast switching speed. Filtering. The rectified voltage is filtered using inductors and capacitors to smooth it out and produce a stable DC output. Feedback mechanism. Feedback control in an SMPS ensures that the output voltage remains stable despite changing in load or input voltage. It typically involves voltage feedback. A portion of the output voltage is fed back to the pulse width modulator controller that through an error amplifier. This feedback loop adjusts the pulse width modulation duty cycle to regulate the output voltage and maintain it within the desired range. Isolation optocouplers are often used in the feedback loop to maintain electrical isolation between the high voltage primary side and the low voltage secondary side. Error amplifier compares output voltage to a reference voltage. Compensation network stabilizes the feedback loop, and the pulse width modulator adjusts the duty cycle of the switch to maintain the desired output voltage. Applications of SMPS: consumer electronics. They can be used in powering desktops, laptop and peripherals, TVs, home theaters, audio systems. Almost all mobile phone chargers uses SMPS technology to convert AC main to the required DC voltage. Industrial applications: SMPS is used to power PLCs, sensors and other control systems in industrial automation. Variable frequency drives and servo drives for controlling motors rely on SMPS for efficient power management. Various industrial machines and tools including welding equipment and CNC machine utilizes SMPS. Medical equipment: MRI machine, X-ray machine and CT scanners require stable and reliable power provided by SMPS. Renewable energy: solar inverters uses SMPS technology to convert DC from solar panel to AC for home or grid use. Portable devices also uses SMPS. Thank you.